Hi everyone, this lesson is about the derivative of the exponential function. So in particular we're looking at y equals e to the power of x. Now remember, e is a special number. It's approximately 2.718 etc, etc, etc. It's an irrational number, so the decimals go on forever with no repeating pattern. So what makes this number e so special? Well, let's use our graphing calculator to take a look at this. If I go to the graphing app, now I've just got a few things there that I'll take away. So if I start with something like 2 to the power of x, this is an exponential function, and now I will use options and calculus, and I'll make a derivative plot of that function. To do a plot over the entire domain, I need to put x here, not a particular value. And let's draw these. Now we can see here that the first one, if I hit trace, y equals 2 to the power of x, this is the blue graph. And as you would expect, if I substitute 2 to the power 0, the value of that function is 1. And the derivative of that function, the slope of the tangent at that point, is about 0.7 roughly. The red graph represents the derivative function. So you can see that it is intersecting here at around about 0.7. If I just use the down arrow to switch to that second function, you can see the value of that function is exactly what we just had, 0.69. So that's literally showing the value of the derivative. I can move a few steps to the right, let's say where x equals 1, y equals 2. Now it's rather steeper with a gradient of 1.3 for my exponential function. And there it is, the value of the red function, the derivative function, is the same, 1.3. Notice that the red function is basically the same shape. It's just that it's always a bit lower. Let's pop back over here and try a base of 3. This time, now it's pretty close, so I'll zoom in a bit. This time, I think we can see that the red graph, the derivative function, is slightly higher. It's above. Once again with trace, this is my function with a derivative just ever so slightly greater than the value of the function itself. Now, if I go and use a base of 2.718288182845 which just happens to be, I think I got that right, just happens to be an approximate value for e. Look at that. The red derivative function is exactly superimposing on top, and if I do a trace of the function, I have a value of the function is 1 and the derivative is 1 as well. So that's what makes that number e so special. And literally, as we've just seen there, we can write that the derivative of this function is exactly the same as the function itself. And that's what makes this such a special function. It's called the exponential function when we use the base e. And okay, e is not a particularly convenient number, but it's the only number that this works for. So the defining characteristic of this function, this is y equals e to the power of x. Now, as we know, the coordinates of this intersection point will be 0, 1, and a tangent line at this point will have a gradient exactly equal to 1 as well, being the value of the function equaling its derivative. Now, it's not just at that point. That's a convenient point to inspect, but it's not just at that point. If I move the trace to the right, so when x equals 1, y equals 2.718, And the derivative at that point, the tangent line at that point, would have a slope of 2.718. Anywhere I care to stop, 1.915, 1.915. Anywhere we like to pick along this function, the derivative value, the slope of the tangent, equals the value of the function itself. So that's what makes this number so important. That's it for the introduction to the number e. Thanks for watching.